What is the force of gravity between this 729 gram bocce ball and this 58 gram tennis ball? What is the force of gravity between the two? What is the acceleration due to gravity on the surface of this bowling ball? This bowling ball weighs 7.26 kilograms and it has a radius of 10. What's the acceleration due to gravity on the surface of this bowling ball? This is the Cavendish experiment. Now, without looking back at your other answers, what is one thing you would do to make this experiment better? Now, for those of you at home, you probably haven't seen this, but this sheet represents the fabric of space and time, okay? And when we put an object into the middle of the sheet and we lift up, what will the sheet do? Will it bend to the object, or will the sheet stay flat? All right, now, how about this? I'm gonna put something in there to make it a little more obvious what the answer is. Will the sheet bend to the object, or will it remain flat? That's right, the sheet will bend to the object. The sheet is bending, and that bending represents the curvature of space-time. Now, unfortunately, I don't have any hands to help me out with this, but it's a really cool demonstration, so when you guys get into class, you will see this. Do you think it is possible for this marble to orbit around this bowling ball? Describe a situation where this marble could orbit around this bowling ball. So why is it that astronauts appear to float in the International Space Station? Why does it look like they're floating? What's actually happening to the astronauts? Check it out, guys. I have a bag here. I'm gonna try and use this to represent gravity, okay? Look at the bottom of the bag. Nice and flat. There's no real bend to it. Now, I'm gonna put this bocce ball in, right? Let's pretend this is space. As soon as we introduce mass to a space, it bends it. It bends the space around it. It bends it to the amount of gravity it has, to the mass it has. Now watch this. It doesn't bend uniformly. Watch what happens when I put a bowling ball into here. Now, I'm gonna do this carefully. I'm not gonna drop it. And I'm gonna pick it up. Look at that. That is a massive bend. It is huge. It is almost warping the entire space around it. It's pulling in the top. It's making it very difficult. This represents a super massive object in space. Now this bend is what causes all things to go towards, that's what the attraction of gravity is. It's the bending of space-time. Gravity isn't like a hook that you send out and you attach something to. Gravity is more so like that ramp back there, where objects just want to go down and keep on going down. There it is, that's the ramp. They want to go down and down the ramp. All right, cool. There's a couple of questions attached to the end of this edpuzzle. They're gonna be about orbital velocity and escape velocity. So if you don't know that yet, go back, watch the videos, try the worksheets out, all right? Orbital velocity and escape velocity.